Greetings and welcome, friends. Mr. Waddy here. We are continuing section 4.1, in which we are writing equations of lines in slope-intercept form based off of kind of a series of clues that we are given. And I've outlined here a particular situation. What do I do if I'm given 2 points and one of my points is not a y-intercept? Right? Like so far, the way the book's problems have been, they've conveniently given us points that were all points where one of them had 0 as its x-coordinate. And so I'm going to outline a couple problems here because this is just like some classic type of problem. Also, I think that it's a really great way to see some of the strength of algebra at work. And so this gets a little bit trickier, but I think it's going to be worth it. So notice for this, this particular problem, notice neither of these points are the y-intercept. How do I know that? How do I know neither of those are the y-intercept? Well, but I also know because none of them have 0 as their x-coordinate. All right, so a y-intercept will always have 0 as its x-coordinate. So what I've outlined for us is kind of like 4 steps as to what do I do if none of those were my y-intercept. So it said first thing I do is find the slope m using the slope formula. Our slope formula is m equals y2 minus y1 over x2 minus x1. So let's label our points x1, y1, x2, y2. This one isn't, so yeah. So these ones I just added today, so find a scrap spot to fit it in there for now. But future generations will enjoy these packet problems, so my apologies. So let's see, so I plug it in. Y2 is 10, minus y1 is 4, over x2 is 3, minus x1 is 1. And so I will get 10 minus 4 is 6, 3 minus 1 is 2, and what is my new m going to be? But that reduces, what is 6 divided by 2? 3. Or 3, yeah, 3 over 1 if I want to really explicitly think about it in terms of rise over run. So I just found my slope. Step 1 is done. All right, step 2. It says plug in your slope for m and one of your points coordinates for x and y in y equals mx plus b. So y equals mx plus b, remember, is slope-intercept form. Slope-intercept form. Okay, so that's the equation of the line that I'm trying to write. And so it's saying plug in m, plug in x and y, and then I'm going to next step solve for b. Now, it actually just says one of your points coordinates. Is there one point here that you like better than the other? Because it actually doesn't matter which one I use. Both of them will work. Which point do you like better? Really, the 3 and the 10, that's fine. You could use 3 and 10. I'm usually just a mathematically efficiently lazy person. I like to aim for smaller numbers myself. So that's why I would have picked it. Or, maybe I would have avoided some negative numbers or something like that. So let's see, there we go. I'm going to plug in, for step 2, plug in what I know and solve for what I don't. So for y equals mx plus b, I'm going to plug in 4 for the y. Actually, let me just write y equals mx plus b here, just so you see exactly what's going in where. All right, so instead of y, I'm plugging in 4. Instead of m, I'm plugging in 3. Instead of x, I'm going to plug in this 1. And b, I don't know yet. B is unknown to us. That's what I'm going to solve for. But all right, let me draw these lines. So 3 from the m. Yep, y1 went here, and x1 went there. Now, if I choose y1, I have to choose x1, all right? I couldn't have chosen this x and that y. That will not help us. That would be a completely different line. All right, so I plug in what I know, and notice what's the unknown that I have here? I have the b that I'm going to solve for. I'm going to solve for the y-intercept. Plug in what I know, solve for what I don't. So that's what their next step is, solve for b. So I'm going to have, let's see, 4 equals 3 plus b. How do I get b by itself here? Yeah, I did 3 times 1. I simplified. How can I get rid of this 3 here? Yeah, perfect. Subtract 3 from both sides. Right, our solving skills are still coming back to us. And I'm going to flip it around. B equals 4 minus 3 is 1. All right, I just solved for b, right? Mystery solved so far. I found my slope using the slope formula, and I found my b by plugging in everything I knew and solving for what I didn't know. And now I can write my equation, right? Write your equation with your found m and b. Now, when I do that, this is what it'll look like. Y equals 3x plus 1 is the equation of the line that passes through those 2 given points. All right, so that's the mystery that we just solved. It's the equation of the line that passes through those 2 given points. Now, one of the tendencies that students have, and I'm tempted, I don't even know if I should tell you, because then will you want to do it because I showed it to you? Sometimes students will then be like, well, wait a minute, shouldn't I have 4 equals 3 times 1 plus 1? And like they'll want to keep plugging these in over here. But I don't want to do that. Now that will result in a true statement. But the equation of the line, when I leave it generically in terms of y and x, it now represents all possible combinations of x and y that make this equation true. And all of those points together form a line. If I plug in only one of my points, I will have a true statement, but it will not be the equation of the line. So you need to make sure that when you write your equation, you only plug in the m and the b. All right, let's do this next one speed quick. Even if maybe you don't even write this next one down, just follow along, all right? So first thing I'm going to do, find the m. I'll label my points. x1, y1, x2, y2. All right, and I'm going to find my m. M is equal to a -4 minus -1 all over 8 minus -4. Ooh, 8 minus -4. So -4 minus -1 is -4 plus 1. Oh boy. What's -4 plus 1 going to be? Wow, man, we got that now. I like that. Yeah, their signs are different. So I subtract them and I take the sign of the more influential, which was the 4. So that's just going to be -3. Over 8 minus -4, that's 8 plus 4. So that's 12. And I'm going to simplify that. I get m equals 3 goes into both of those. 3 goes into 3 once and into 12 4 times. So m is equal to -1/4. Yes, very good. All right. I still need to find b. How did I find b? Do you guys remember? I plug in what I know and solve for what I don't. I plug in my new m. I plug in one of my points for x and y, and I'm going to solve it. All right, so for my equation, y equals mx plus b. Right, you guys are just following along, right, absorbing this information. I plug in what I know and solve for what I don't. Do any of those points, I don't know, they're both kind of, they both have negatives in them. I don't know, maybe I'll just pick this one. I'll plug in this point. So -1 goes in for y. What goes in for m? -1/4 multiplied by x. Well, I already used this y1, so I've got to use that x1. So -4 plus b. And now, behold, I have an equation with only one variable in it, which is b, which is what I'm looking for, right? If I can find this guy's y-intercept, I'll know which line it is. I could narrow it down, because right now there are infinitely many lines with -1/4. Any line could have been the murderer that has a slope of -1/4. But no, we're on to this guy. Using process of elimination, there's only one value of b that could ever work in this equation. We're solving this mystery, friends. Let's see. So -1 equals, all right, this one's crazy. Does anyone know how to simplify that? Well, let's see. You said it a little bit backwards. You could have multiplied the 4 times 1 and gotten 4, and 4 divided by 4 is 1. I view it this way. These cancel out, the 4's cancel out, the minus signs cancel out, and I'm left with 1. 1 plus b. How do I get b by itself? Yeah, subtract 1 both sides. And that's going to become more negative. So I'll get b equals -2. And what is my equation? Y equals -1/4 x, right? Plus -2, which I'll just simplify to be -2. Guys, this line almost got away, but I knew that there could only have been one line that passed through 2 points that are not the same point. And we solved it, friends. We solved the mystery. We can sleep safe at night now. Okay, here we go. Let's do, I got to do example 4. All right, example 4. This will actually be an easier problem. Bing. It's just using function notation. All right. It says write a linear function f. All right, so instead of y equals mx plus b, I'm going to have f of x equals mx plus b. That's okay. With the values f of 0 equals 10, which I want to point out, what that means is when x is 0, y was 10, and f of 6 equals 34. So that means when x was 6, y was 34. Now, are either of those points my y-intercept? Then you remember how I can tell? A 0 for an x coordinate means that this would be the y-intercept. So I can actually immediately say b equals 10 because it had 0 for a y coordinate. If it didn't, then I would have had to rely on that crazy long method that I just showed you, right? Where I would have found the slope using this, then I would have plugged in what I know, solved for what I didn't, right? All that work. But this one, conveniently, they gave me the y-intercept. I do still have to find the slope. How can I find the slope between 2 points? Using the slope formula, friends. Label your points and slap a slope. M is going to equal y2, so that's 34, minus y1, which is 10, over x2 minus x1. So that's 24/6. What does that simplify to become? 24 divided by 6? Anybody? That is 4. There we go. I knew we knew it. I knew we knew it. M equals 4. See, B equals 10. And now I can write my equation. But remember, they wanted this equation with function notation instead of just y, which those are essentially, they're exactly the same thing. It's just two different. One is when like y is just hanging out with friends, and then the other is like formal attire. It's like, no, I'm going to put on a tuxedo. Y is looking good tonight. That dependent variable is looking so formal with its function notation, right? We call it Mr. output on an evening like tonight when it's f of x. So here we go. So I'll have f of x equals 4x plus 10. Wow. Fancy pants. Wow. I'm impressed. All right, let's see. I want to jump right down to a word problem, doing some modeling here. All right, you guys already got this written down, so we're skipping a couple examples. That's fine. It says a linear model, okay, is a linear function that models or represents a real-life situation. When a quantity y changes at a constant rate with respect to a quantity x, you can use the equation y equals mx plus b to model the equation. So when there's a constant rate, then we can use a linear equation, y equals mx plus b. The value m is the constant rate of change, or our slope, right? So m. And the value of b is the initial or starting value for my output. Okay, so these are going to be a little bit scarier, but don't you worry. We'll get through this together. We're a team, right? We've already solved some of these mysteries, right? We're going to solve this one too. All right, modeling with mathematics. Look at, guys, there's so many words and hardly any numbers. All right, breathe. Okay, oh my goodness. Whoa, look at these words. There's so many letters and syllables. Excluding hydropower, what are these words even meaning? Okay, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. All right, sure, thank you. Let's keep reading and find out what we know. All right, by the year 2012, the amount of electricity generated increased, wait a minute. Guys, that sounds like change, right? Increased. I'm thinking change. Hopefully we can find a rate of change here somewhere to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropowered renewable energy. Wow, that's like so many words here. Sources as a function of the number of years since 2007. Okay, we might have to recognize our independent and dependent variables here. And then use the model to predict the number of megawatt hours that will be generated in 2017. All right. Now it said that they said the word function of f of x. Here's my x. Okay, this is my x, right? Notice that, f of x, right? Bam, you saw it there. It's like hiding right there. Okay, so that's my x. What is the output? The linear model that represents the output, I'll do y in purple, I guess. The number of megawatt hours generated by non-hydropower, renewable energy sources. Okay, so y is measuring megawatt hours generated. All right, so there's my y. Now, what do I know? All right, okay. Let's breathe. Now, x is the number of years since 2007. So what is x in the year 2007? When I'm in the year 2007, how many years has it been since 2007? If I'm in 2007, I'm saying. So during the year 2007, it has been 0 years since 2007. Yeah. And how much megawatt hours of electricity were produced? 105 million. I'm just going to call this 105. Let's refer to the y in millions. Maybe we can change that because that sounds like that would be easier. In millions. Right? Because I don't want to have to think of these graphs as being massive things. Okay? All right? So there's 1 point. All right, let's figure out another fact they gave us. That's what these were. These were facts, and now I'm interpreting them into something that I can model. All right, by 2012, question, how many years has it been since 2007 in the year 2012? right? If I do 2012 subtract 2007, that's equal to 5. That means my second fact has an x coordinate of 5, right? So 5 years since 2007. What was my output? What was the megawatt hours in millions? 219. Okay? All right, it's a little bit crazy interpreting this, I realize. So, let's see if we can write an equation. What I need to do is find the slope. So let's actually label this x1, y1, x2, y2. Let's find our slope. M equals. All right, the y, 219 minus the y1, right, 105 over 5 minus 0. You could reach for a calculator here. Let's see, 219 minus 105. I get 114 over 5 minus 0 is 5. That is not divisible, but that is my m. Here, we still got time. We got 3 minutes. Don't pack up yet. So there's my m. What is my y-intercept? My y-intercept is my starting value. What was my starting value? 105. I also know that because it has an x coordinate of 0, 105. So that means my equation yeah, there's my equation. I like it. And now they asked us this other part B. It says use the model to predict the number of megawatt hours that will be generated in 2017. So question for part B, what is the input in 2017? 2017 is how many years since 2005? Well, let's subtract, 2007. That's equal to 10. So that means what I'm going to do here, stay seated, don't pack up. Y equals 114 over 5, plugging in 10 for x, plus 105. Let's simplify this. So 114 plus 105. Let's see. I get y equals 333. What that means is in 2017, we predict we will have 333 million megawatt hours produced. Right? So that's how we predict it. Bam. All right, thanks for watching, internet friends. Have a good day, everybody. Bye-bye.